Part 3, using linear equations to solve word problems. So in this part, we not only have to convert any word problem into an equation, and we also need to solve it. Part A, we'll use all these examples to demonstrate how to do this. Part A, 7 more than twice that what number equals to 35? What number? Let's assume that's unknown variable x. 7 more than twice. So you add 7 to twice of that number equals to 35. So we have demonstrated how to solve this equation, right? We minus 7 on both left-hand side and right-hand side, and that would give you a 2x on the left and 35 minus 7 on the right-hand side, which is 28. So 2x equals to 28. Now we divide 2 to both sides to get to x equals to 14. So eventually, for all these problems, x equals to what number is the final form that we are striving for. Part B, 6 plus half a number. Say that number is unknown y. Half a number is 1/2, right? Equals to 8 plus 1/3 of the same number. So this is the equation that we are trying to solve. So there's a 6, there's an 8. We can get rid of 6 on the left-hand side, which is by minus 6 to both sides. So we have 1/2 of y equals to 8 minus 6 plus 1/3 of y. So students can do it in two different ways. If we can do it as 1/2 y minus 1/3 of y equals to 2. So this is 1/3. I minus 1/3 to each side, so this term would cancel. So right-hand side would just be 2. So how do we solve this? As we said, this is a reverse of the distributive property. So we can do 1/2 minus 1/3 multiply y equals to 2. So 1/2 minus 1/3, students know how to solve, which is 1/6. Y equals to 2. We multiply 6 to each side to get to y equals to 12. In this problem, we can also do it in a different way, which is once we get to this equation, we can multiply 6 to each side. If we multiply 6 to the left-hand side, I would have 3y. If I multiply 6 to the right-hand side, I would have 12 plus 2y. Now we minus 2y to both sides to get to y equals to 12. So you can see that two different ways would give you the same answer. Part C, when you add 12 to a number, say that number is unknown variable x, then divide the sum by 13. The sum by 13. You get the same result as when you subtract 13 from the number and divide the difference by 12. What is the unknown number? X. So this problem we'll leave for the students to figure out. So students can see that 13 and 12, the least common multiples are the multiplication of 13 and 12. So we can multiply 12 first to both sides and multiply again 13 to both sides to get to, and then collect the like terms to get to the final answer. Part D, my sister and I are buying a TV for our room. Because I'm older, I'll pay $45 more than my sister. If the television costs $299, then how much does my sister have to pay? Okay, say each person, say my sister pays an unknown variable y dollars for the TV. And I will have to pay y plus 45, right? Because I'm older, I pay $45 more. And the two of us combined together will pay the total of $299. Now we can solve for y. Y stands for my sister, how much money my sister has to pay. For myself, I'll have to pay 45 more.